I'd like to bring up our next guest speaker. It's Jaikumar Ganesha from Anyscale. He's going to talk about their managed AI/ML platform that also sits on top of AWS and can be an instrumental part of database focused data and analytics based workloads. So come on up.
All right. My name is Jaikumar, also go by JK. I lead engineering at Anyscale, and previously I spent some time at Uber ML Infra, as well as was one of the early team members at Android way back in 2006. So Kamal talked about how you take an idea and try to get it to product and application. He's now happy and excited. Oh, I have a control plane solution. I have all these awesome agents that I can actually build. So many use cases that were not possible before. Let's get into it. He was an ML developer. He started his doing structured XGBoost model some time back. Then deep learning came along, and then he started doing it unstructured data. Hey, I can process a lot more of data much more faster. And now generative AI has come along. You have your audio, video, chats, conversation agents. You run on GPUs, CPUs, multi-node distributed stuff. He's like, all right, I got this. Let's go. So he's got his data sources. He's got his data sources, sensor data. He's got audio, video, structured, unstructured data, everything there. Then he says, OK, I have 1 million models on Hugging Face. I need to pick one. Let's start with data preprocessing. I have Spark, I have NumPy, I have Pandas. Oh my goodness, I've got CPU infra team to deal with. That's fine. He figures it out. And goes to, OK, I can train a model now. Which framework should I use? Should I use PyTorch? Should I use TensorFlow? Should I use XGBoost? Oh boy, and I have to deal with GPU infra also. All right, he's somehow figured it out. He's smart anyway. And then he's now coming to model serving. And now he has got the latest LLM inference engines. VLLM, TRT-LLM, deep speed, CPU and GPU infra team. This is a lot. How many of you have gotten stuck trying to build an AI application and just gotten stuck by the complexities and the entire frameworks changing every single day, right? I saw a few hands go up. We call it the AI complexity wall. Right? So it's literally a wall that Kamal is now frustrated, and he's hitting the AI complexity wall. And here are some data points. Only 1 in 10 AI projects actually make it to production. People get excited with all the latest models and do it on their laptops, but only 1 in 10 go into production. 93% of companies leave their GPUs unused. Unstructured and multimodal data is growing, and models and frameworks are growing fast in size and complexity. Ray was actually built for this. So Ray started as a PhD project in around 2016, 2017. It basically has 2 concepts for a user. It's a Python function, we call it tasks, and a Python class, we call it actors. You don't have to look at the code, but it's basically on the left-hand side, tasks is taking a matrix multiplication and just distributing it. It has like 4 or 5 APIs. And then actors has some state. So here's a counter that you can actually increment, and again, you can actually distribute all of these things. So below it is Ray Core. And so Ray Core is what is a compute substrate layer. It takes care of all your CPUs, GPUs, has a scheduler, has a distributed object shared memory, takes care of all these nodes. If a node crashes, it brings it up, etc. And then on top of that, we have built various machine learning libraries. Serve for serving your models, data for data processing for the models, training the models, reinforcement learning, and LLM and post-training models too. So initially, around 2019, Ant Group was the first company which actually started it, using Ray a lot. And then Uber, I was on the Uber side, we started using Ray internally for building ML platform systems, and Michelangelo is a famous framework from Uber. And then Pinterest also started using it a lot. So these were like 3 of the big companies who are using open source Ray and working with us and driving a lot of adoption. And then generative AI came along, and this just exploded. These are all some of the companies, and Amazon here too, and quite a few of them started using Ray extensively. Every single day, I hear about one new company using Ray. Tencent uses it for WeChat extensively. Just last week, we came to know that X.AI is using it for data processing. Thinking Machines, that's the latest startup, is also using Ray internally. So this ecosystem has grown a lot. All right, so I want to take a step back and talk about all the trends that have happened in AI over the last 1 or 2 years. So data processing. Initially, it started with SQL data in tables. It's gone now into multimodal data with images, video, audio, text sensors. Data was basically, you process the data and you have some batch stuff. You can write some SQL queries. That's how it was being done. But now it's tightly connected to inference. You have a chatbot and you're asking something of, say, a legal document, right? So you have to process the data and also do inference on it at the same time. From CPUs, we have now moved to CPUs plus GPUs, plus all the custom TPUs and inferentia chipsets and various other hardware frameworks. So there's a shift in the nature from SQL on CPUs to inference on GPUs. That's actually happening and continues to happen. The second trend is agentic AI. These are two figures that DataRobot actually published on what it takes to build agents. From one model, it's gone to a compound AI system. It's a collection of models now, right? Now you have a RAG system, that's fine, but now you need a ranker on top of it to figure out how do you actually rank the results. You need an embedding system to figure out what kind of embedding you want to use. The programming model has changed, right? Initially, we used to write code in C, C++, etc. Then it went to neural networks where we are changing weights. Now LLMs and prompts are become their own programming model, right? So now you have to do prompt management. How do you actually do that? You have to deal with prompt injection and stuff like that, right? Which is the LLM that I need to choose? There are some LLMs which are good for one single small node and some models which are big with higher accuracy, for example, but need multiple nodes for that to run, right? So there's so much more complexity that is actually to be handled to build these agents. And Ray is best suited, again, to take care of this for you. The third trend that's coming on is post-training. So you have these pre-training, which is like, all the LLM models that started a couple of years back. They had this first models that they used to run on large number of GPUs, some open source like Llama, some proprietary coming from Anthropic and OpenAI. Now, post-training is a trend where you take one of these models and you train it for a specific purpose. Now, if you're an agent, say if you use Cursor, right, and your Cursor is using a post-trained model which is developed for coding, or if you are using one of the reasoning models, latest ones from OpenAI, say O3, that's also a post-trained model, right? A lot of the post-training frameworks are actually built on top of Ray. OpenRLHF, Whirl, SkyRL, all these are famous open source post-training models. They're built on top of Ray. So let's take a little bit of a deeper dive over here. So the pink box that you actually see is still the learning algorithm. It usually uses PyTorch, FSDP, or Megatron if you're familiar with those frameworks. And then you have this inference, which is an actor, which rolls out your rewards, and you have to infer it. And now you have a loop. So you are a coding agent now, and you are suggesting some steps. Now you have to run a unit test, for example, and you have to come back. So you actually interact with the environment a lot. And that's what agents will have to do. If you have agents with which are connecting to multiple other agents and multiple other models, and they're doing like solving a problem, they are optimizing for a reward. And you have to train that agent for that reward. They have to continuously work with the environment, right? It's very different from the olden times where you have a model, recommendation model, for example, you click a button, you get it, right? It's now you are in this continuous loop. So what happens is that what runs on CPU? What runs on GPU? How do I actually move the weights from one node to another node? How do I actually combine all these aspects, right? And this is where Ray, again, comes into the picture. Many of these post-training frameworks are actually built on top of Ray. All right. So I talked about the AI data processing, agentic AI post-training, the AI workloads. Obviously, at the bottom of it is the compute substrate. You have your cloud providers, AWS and others, your specialized GPU providers, etc. And the AI infra software stack sits in the middle. Right? this picture is from Roblox. They published their entire AI infra software stack. You have various parts of it. So you have the compute substrate. You have like, frameworks. Then you have the real-time inference engines. You have all your data stuff on, unstructured data, data structure, your feature stores, your tables, etc. And then you have something like, if you need streaming framework, something like Kafka to connect all these components. And then you have your testing, experimentation, and monitoring frameworks. So let's abstract it away a bit more. So let's talk about like, training and inference frameworks. There are basically two main frameworks here, PyTorch and JAX. JAX is now only on TPUs. PyTorch has become the dominant one. And because of the size of the models, you have to have different parallelism strategies, right? And so FSDP and Deep Speed are two major frameworks that drive the different kinds of parallelism strategies. And for the LLM inference, these are the transformers. They get their own box. It's no longer just serving a model and running up a service and serving a model, right? You have to think about if you're familiar with the LLM space, you have to think about things like chunk prefill. How do I do prefill and decode stages? How do I actually make sure that continuous batching? Because again, every single token that you type in, there is an inference engine that's actually running. Can I predict what the next word is going to come so that I can save my costs? Many times, if there are multiple users sending in the same request, they all have shared prefixes, right? What's the weather in Palo Alto, or what's the weather in San Francisco? So I can be smart enough that I can know that what's the weather is actually a common pattern. So there is so much complexity over here within LLM inference engine, and this is continuing to grow. So VLLM is one of the most popular open source LLM inference engines. Then the distributed compute layer is where Ray shines. Ray basically makes sure that it takes care of scheduling, it takes care of auto-scaling. And Spark was there for the ETL data processing, and we are also seeing some homegrown solutions over here. And of course, you have the container orchestrator. Kubernetes is the leading container orchestrator. Some of the ML research groups use Slurm. The reason for that is like Kubernetes is just too complicated, and Slurm is a very simple job manager, and you also have VMs. So I'll just pause there for people to get an idea of the evolving tech stack here. Right? So I'll give you some examples here. This is all from open source. Instacart was able to train larger models using just 100x larger training data. Niantic saw developer productivity, and Amazon moved to Ray data and were able to save around 100+ million in cost by using Ray data for their data processing needs. The Ray community since 2019 has grown a lot. We host a Ray summit every year, and there's one more in November. This is right here in San Francisco. I would encourage people to attend that. Right. So let's come back to Kamal. He gets it. He understands the AI complexity well. He says, OK, fine, you've explained this to me, but what do I do with it? How do I apply it to my use case? Right? So let's take a simple use case and deep dive a bit. So he wants to process some multimodal data. Right? And so I'll give some of the APIs that he can actually use to develop his application. So multimodal data has grown a lot. Obviously, it's being used in healthcare for analysis of X-rays, etc. This has been going on for some time, but it's actually going to increase a lot more. Sensor data is flowing from various geolocations. So think of like Uber, Lyft, or Waymo, etc. They're all collecting data, and they have to make sense of the data. Industrial automation has picked up a lot, and of course robotics, right? So all of this is generating a lot more of multimodal data. Market cap also is supposed to grow, like from 1.7 billion to 68 billion in the next 10 years. So the question for us is, what's the best data processing framework and architecture for handling multimodal data? Firstly, do we need to change anything? What was working before, will that just continue to work? Will it be efficient? So previously, the core assumptions we were making was that data is structured and tabular. Bottlenecks are like CPU and memory based, and operators are cheap and lightweight. They were based in Java and Scala. Right? If you've dealt with it, you deal with ETL pipelines, your data frames, your SQL queries. AI data processing systems have changed the requirements. It's not just tables. Now you're dealing with tables and tensors, right? Bottlenecks are not just CPUs. You have GPUs, CPUs, and memory. Sometimes between stages, you may have to materialize the data. Or if you don't have enough memory, that's going to have an impact on the throughput of the system. And because you're dealing with so much amount of data, operators are going to be heavy at every stage of it. And the AI ecosystem is in Python. So Ray Data is a data processing engine that's actually built for AI workload. It has support for multimodal data from the ground up. It's not like bolted upon on a legacy system. You have readers for images, video, data. The backend is based on ML frameworks like PyArrow, NumPy, Pandas. It has first-class support for GPUs, TPUs, optimized GPU pipelines, and can handle both CPUs and GPUs at the same time. The stateful operators, because for expensive GPU state, you have to have stateful operators, and that's actually built in. And it's written in Python, supports all the data sources, Parquet, Iceberg, Delta, Hootie, etc. And then it also has integration with inference engines. Coming back to the point I made, it's no longer just regular processing, it's regular plus inference. So Ray Data works with VLLM as well as GLang, two of the famous open source LLM inference engines. Let's take a quick dive into the API. So you have standard read and write APIs, right? Parquet, JSON, etc. And you have connectors to all the DBs. You can do a transform on the data. Hey, I want to map batches, basically distribute my processing on it. You can consume the data. I just want to iterate through the rows of the result, just take one. I can do aggregations. So anyone who has worked with data, all of this will be pretty familiar. I think the difference here is the compute APIs. You can actually now specify your CPUs, GPUs, and the concurrency that you actually want to provide. So let's take an example. I have a standard computer vision application, right? I have a bunch of images. Say it's there in my S3 bucket. Now I want to make sense of these images. I want to classify these images. So now I'm going to have these three stages. I do resize these images. I have a segmentation model, which is going to segment the images. And then I have a classification model, which is going to classify it. And then I'm going to write the images down. And for the keen eye, you'll notice that these are three stages. There are three map batches operations. And you'll also notice that segmentation model, the concurrency is different than the classification model. So I can actually control, hey, this just requires one GPU. This can be done in half fractional GPU. And this can go with a concurrency of 8. This can go with a concurrency of 4. So what does it look like in an array cluster? We have some tasks like resizing of image, good for CPU. Segmentation model and classification model requires GPUs. So we run that on GPUs, and then we are able to write it back using CPUs. So the two key aspects here is heterogeneous architectures. You need to do CPUs and GPUs at the same time. And the second thing is your data is streamed through memory because it's built on Ray core. So after a stage, it's not like, oh, I have to write it back to the S3 bucket and then load it in a GPU. For the legacy systems, that's how you need to do it. And the fun part is that it's also streamed. You don't have to worry about it. And the execution can happen in a streamlined way. So what do I mean by that? Suppose you have 1,000 images, 100 of them have been resized. You can send it to the GPU, and the GPU can start working on it. You don't have to wait for all the 1,000 images to be processed by stage, and then you lose your GPUs idle. Same thing with the classification model. These GPUs are not cheap, and utilization is an important aspect over here. All right, you'll see a lot more details on docs.ray.io. This is all open source docs. All these use cases, examples, everything is actually provided over here. So I would encourage you to visit there. You have tons, all the libraries, examples, etc. All right. So now Kamal gets it. He's like, I know what to write. He's written pip install Ray and figured it out. But getting everything out of Ray requires a lot of major investments. We have seen teams get blocked in getting started, and they run into production, and then they expand across teams. Right? This is where Anyscale comes in. Anyscale takes infrastructure away from you. You don't have to worry about it, especially if you're spinning up infrastructure on top of Ray. So developer velocity. So Ray is like a Formula 1 engine. It really requires an expert to truly understand what they're doing, right? But it comes without the rest of it. It doesn't have the doors, the seats, the knobs, etc. And so we have a developer experience portal. We have observability. How do you better manage the instance? What about costs? And if you have to do an upgrade, etc. All comes in packaged at Anyscale. Production resilience is the thing. You may run Ray, you will run out of memory, your GPUs will fail. What happens when you have to checkpoint a job? That resizing image, what happens after your GPU fails after 10 images, right? What happens when you have a spot instance and you want to move to the spot instance, but you got preempted and you want to go back to the on-demand instance? The control plane can also be intelligent, and you can have the Ray control plane. You can have job level retries. You can do checkpointing, etc. Cost matters to everyone, right? So we also have optimized runtime within Anyscale of Ray, and so this is elastic training using spot instances, making it easier for higher QPS. And then when multi-AZ deployment, as well as scheduling based on when your reservation, when a node is available, say on the weekend, we can actually schedule those jobs. So this is basically Ray on Anyscale, heterogeneous infrastructure, bunch of ML use cases that can be built with them. Some of our customers, like Runwave, which is a GenAI company, deploys it in production. Attentive, Coinbase, etc. have seen lots of improvements in their developer efficiency, in their production, in their cost use cases using Anyscale. All right, let me do you a quick demo here of our developer experience. So you have this concept of a workspace that's there. And here we are actually creating an audio application, and you don't have to worry about worker nodes, for example. You say, hey, auto select nodes. That basically means that we will figure out the right instance to actually use an autoscale, etc. You are integrated with your VS Code, and you are writing some code over here. As you run it, you said, oh, I don't have a dependency management problem, no module named datasets. Now, if you are doing a distributed applications with dependency management, what do you have to do? You have to go to every single node SSH and install the dependency. But we have actually created this where a container image using a Docker, this automatically will install to all the worker nodes without you having to actually and restart and get going, right? And so now when the user runs it, it'll actually work through it. There are other aspects too over here. So for example, now we automatically auto-scale. So you can see this on the top right, this one node, and now it's automatically scaling to 2 nodes without you actually having to worry about it. And this is where the power of Ray comes in. You want to metrics, how the hardware is being utilized. If you want to know, hey, what is my utilization of my CPU, GPU? And then if you want to go deeper into the workloads, logs, etc., everything is available in a single pane. This is something that is really resonating with our users, that one single plane where they can actually develop their application, see what's happening with the Ray cluster, and also deploy into production. All right, to recap, newer modalities of data processing, agentic AI, post-training, different use cases is leading to the AI complexity war. Ray was built to solve this, and Anyscale makes it easier to take it to production. So you can try today. Go to console.anyscale.com. You can try today. We have an open source community. You can join there. You can get expert training. Like I said, Ray is still an engine, a Formula 1 engine. You can get expert training to actually learn more. So hopefully our AI developer who started with an idea, ran into the problems, found a solution, and is able to deploy it into production. With that, hopefully this was all useful to everyone here. Thanks a lot.